ठीक है. Last lecture we were discussing the features of the 8085. Today we are going to discuss the architecture of 8085 is there. So this is the architecture. One by one we are discussing this. First part of this architecture is this is the kit. Somebody asked me to how the kit is look like. This is the kit which is present in your lab. This is the kit. This is the display where you have to see the output of this. This is the keyboard, and this is the keys, reset keys, and del key. From that you have to put the data on this your keys, and in your this is the see here. This is the chip of the 8085. This is the chip of the 8085. This is the keyboard where you have to give the input to the 8085 is there. Okay. For the peripheral device, you have to connect here the peripheral device. Then here is the power supply where you have to give the 5-volt supply to them. And here is the some memory and some slots are there to increase the memory. There 8 to 7. These are the see this is the EEPROM, this is the RAM, this is the memory. You have to extend the memories there. This the 8 to 5 is required to connect to the external means you have to connect to the keyboard or mouse. Sorry, not you have to get a keypad or LCD displays there. For that purpose, we have to use the this one is the peripheral device, and for that purpose, we have to use another IC. This is called out 8255 is the IC. From this, you have to connect the 8085 to the peripheral devices are there. And here is the 8085 there. This is the 8085 there. So this is the IC of the 40 pin IC 8085. It is connected to this. This is our RAM is there where you have to store the data, and this is your 8279 for the display purpose. So this is the 8085 kit is there. If you get the lab, then you can see how to give the input to the 8085 through this kit is there. So this is the kit is there for 8085 is there. Okay. Practically जरा when we see the practical आपल्या मिळालं तर आपण ते पाहूयात कसं input करायचं and how to get the output from this 8085 is there. Kit is there. या डिस्प्लेवरतीच आपल्याला आउटपुट दिसत suppose addition of two numbers, subtraction of two numbers, multiplication of two numbers. You have to put the data from here and then you will get the output is there. So input is not given in English language. If you are writing the program in English, move a comma b, this is the instruction is there, but you are not writing the move a comma b is here. You have to put the hex value by using this keyboard, and then you have to give the input to the these keys are there. So we have to put the directly hex value in our C programming or 8051 program. What we have to write the program in editor or editor is there, and directly this assembler or editor is convert this program into the binary. But for the 8085 kit, we can't write the program in English. We have to give the input to this 8085 kit through the which one through the hex is there. There are some kits are there. You have to write the program and directly or go to the 8085, but this is a kit is there where you have to put the values in the hex form. So first you have to write the program, then you have to see the hex value of each and every line is there. Then you can put the each and every line in the hex code, and then put this hex code in this kit is there one by one. Then you will get the output is there. Okay, so this is the 8085 kit. So we'll go to the next is the architecture of this one by one. First is the arithmetic and logic unit. See, first is the arithmetic logic unit. What he is doing, this is used for the arithmetic and logic purpose. This is used for the arithmetic and logic operations are there. These arithmetic and logic operations are there. Which what part is this is the content accumulator, temp resistor, ALU is present, and 5 flag register. What is mean by flag register? We'll discuss in this is there. The logical operation means what? And or XOR is there. And arithmetic operation means addition, subtraction, multiplication, arithmetic operation. Then timing and control circuits are there, and they perform the arithmetic by the and result is stored into the where result you have to store the result in the accumulator and also store a result in the flag register. See, this is the this our what is ALU part is this is our ALU part is there. This is accumulator, temp resistor, and flags are there. See, this flag is given to the input to the ALU is given to the output to the flags are there. This is the first part of this our architecture is ALU accumulator, where you have to store the register, sorry, you have to store the result in the accumulator. Temporary use for the microprocessor for the temporary storage of the data. And flags are the 5 types of the flags. We're discussing the flags in next part. Then in that flags you have to put the values of ALU to the these flags as well. Result is stored in the accumulator and the flags will be generated. Okay, so this is the working of your ALU user. See, this is the ALU means arithmetic logic. What he is doing, it is taking the register from value from the temp register. This is the temp register. This is the temp registers are there. From the temp register, you have to take the value to the ALU. Also, it takes the value from the accumulator. Also, it takes the value from the accumulator and temp register. Do the addition of this in the ALU. Then you have to send the result. You have to send the result to the accumulator. You have to send the result to the accumulator, and also result is status to the flag register. You have to status this to the flag registers are there. Means what is meant of ALU? ALU is doing take the values from the temp register, also take the values from the accumulator, do the calculation in that ALU part, and then result is for transfer to the accumulator, and then go to the result. You must first transfer this result into the accumulator, and after that accumulator you have to store the result in any memory where you want to store this. Where you want to store this. This is the working of the arithmetic logic unit is there. This is the working of the arithmetic logic unit is there. Understood? This is the working of the accumulator and flag register. See, this is the register groups are there. This is the ALU. Next part is the register groups. In that register groups, what is the type of register is? First register is the temporary register. First register is the temporary register is there. First is the temporary register is there. First is this a temperature? See, this is a temperature W and L. What is use of this W and L is only used by processor. It is only used by the processor. It is not used by the user. User means what? We are not use this register. This is only for the user. Processor is there. Then these are the general purpose register B, C, D, E, L, H, L. These are the 8-bit register. This is the 8-bit registers are the general purpose register. Second, second is the special purpose register are the 8-bit 8-bit accumulator is there. This one is the 8-bit accumulator is there. This one is the 8-bit accumulator. There is special purpose register is there. Second is the flag register. We are discussing the flag register. 5 flags are there. We are going to state. Next is the instruction for store the instruction. Instruction registers are there. Then 16 program counter registers are there. And then next is the stack pointer register. Next is the stack pointer. See here, this is the one part we are discussing the this is the one part we are discussing here. This is the first part we are discussing. ALU contain the accumulator, temporary register, flag, and ALU is there. Okay. Then another part is our is the register. What register? It is the instruction register. Instruction decoder is there. Okay. Then we are discussing the this is the temporary register W, H, and L, and these are the 8-bit register. What is 8-bit register? B, C, D, E, and HL is there. Another register is the stack pointer, and next is the program counter. Stack pointer, and next the program counter, and that for that purpose this is the next part of the register select is there. This is the register select is there. Okay, so one by one discussing what is the use of that. See, temporary register. What is use of the temporary register? Temporary registers are W and Z. Temporary registers are the W and Z. These are the temporary registers are there. They are not available used for the only it is used into the microprocessor. It is only for used in the microprocessor. It is not available for the users. It is not available for the users. See, this is very important question at the time of your online examination also, and at the time of the oral examination also. What is the temporary register? Temporary register is W and Z. It is only used for the microprocessor. It is not available for this register is not available for the users. It is only available for your microprocessor is there. Okay, so what is use of these registers are there? Can carry the operand during the arithmetic. What is going to be the operand? We'll discuss in the when you are discussing the instructions, then we'll discuss what is the operand is there. So only one remember thing is that it is only used to carry the operand during the arithmetic and logic operations, because data is transferred by using the another registers. It is only transfer the operand there. We're discussing this operand in next part when we are discussing the instruction of the 8085 is there. So Next is the BCD. This is general purpose registers are there. This is the general purpose register are there. BCD. See, how many registers of the BCD general purpose registers are there? 6. How many registers are there? 6 registers. Which are then? These are the 6 registers there. B, C, D, E, H, L are the 6 registers are there. Okay. These registers are used for the users. You can use these registers for the users are there. Okay. So what is use of that registers are there? You can transfer the data, you can transfer the results, and you can transfer the memory location is there. Means by using 6 registers, you transfer the data also, you can transfer the result also, and you can transfer the memory locations where the data is and the data is stored. So this is a use of the general purpose register. Then these are the 8-bit registers. See, these are the how many bits registers? 8-bit. Accumulator is also 8-bit, and this one is also 8-bit registers is there. Okay. But if you want to store the 16-bit data, if you want to store the 16-bit data, what we have to do? If you want to store the 16-bit data, what we have to do? So for that purpose, we have to pair these registers, pair them by their own, pair the register pair किया जाता है. You have to, how to pair the register? You have to pair the BC register, DE and HL, but you can't create a pair like B and L. You can't pair like D and H. You can't pair like C and E is there, because the user cannot form the register pair by own choice. This is very important part of your 8085 is there. You have to transfer the 8-bit 16-bit data. You have to make the addition of the 16-bit data. For that purpose, you have to make the pair of this general purpose register. But the general purpose registers pair by your microprocessor. What? BC, D, and HL. These are the 3 pair of general purpose register where you have to transfer the 16-bit data. So this is very important part of the general purpose register, because you can't create your own pairs. Means user cannot create their own pair to transfer the data of 16-bit data. It must be created by microprocessor. Means it is bit created by those who are create a microprocessor. They create a, this one is there. Okay, they create the data is there. So you must remember these things. You cannot create the pair of the data is there. So this is general purpose register is there. Okay. So first register is the temp register, W and L. Second register are the general purpose registers are there. The next is the special purpose register. Specially they are used for something is there. General purpose means that users can use anything, but general special means they are required for the something. So this is a special purpose register. This is the accumulator. Accumulator is special purpose register. Why it is called special purpose register? Because it is 8-bit register is there. It is the 8-bit register is there. It is 8-bit register. म्यूट करा ऋषिकेश. ऋषिकेश म्यूट करा. ऋषिकेश. 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 ठीक है. This is the arithmetic and logic operations are there. This is the arithmetic and logic operations. There are 8-bit is there. 8-bit purpose means ALU is used for the arithmetic and logic operations are there. This is called the special purpose register. This is called the special purpose registers are there. This is called the special purpose registers are there. This accumulator is there. I'm discussing a lot of times this accumulator is there. Then go to the flag register. Then go to the flag registers are there. In that flag register, see, these are the flag registers: carry flag, auxiliary carry flag, zero flag, sign flag, and parity flag is there. So what is meant by the carry? If the operation performed in ALU generates a carry, if our operation is performed generates a carry, then carry flag will be set. Set means what? You have to put a value 1 into the carry flag. If you set means what? You have to put a value of carry flag in the carry into the 1, that is called the set. So how this operation is performed? See, suppose okay, these are the two numbers are there. Okay, these are the two numbers. You have to add these two numbers. Okay, if you add these two numbers, what you know that binary addition is there. Binary addition. You have to add this number means what is the binary addition is there. If 1 plus 1, it is what is the addition of this 1 plus 1 is there. Okay. See, just I am giving one addition is there. If it is 1 plus 1, it is addition is 0. It is 0 addition is there. You have to put a carry is 1. Okay. You know that if 1 plus 1, what is the addition of this 1 plus 1 in your binary is there? If 1 plus 1 addition is, you have to 0 is the addition and carry is, see by carry is 1 is there. Okay, understood. 1 plus 1 means addition is 0 and carry is 1 is there. So same thing is there where your carry flag will be generated if last digit means D0 to D7, 8-bit digits are there means these raw digits. If you add this 1 plus 1, what will happen? Answer is 0 and you have to generate a 1 is there. This 1 generated by the last two digits. This 1 is generated by these last two digits. Then your carry flag will be generated. Your carry flag will be generated. Okay. Your carry flag will be generated. Understood? Okay, means if last digit is generate a 1, then this carry flag will generate. Auxiliary carry means what? See, D0 to D3 and upper nibble is D0, D4 to D7. When upper nibble will generate a 1 carry, then this auxiliary carry will be generated. See, in our example, this D0, D1, D2 and D3, this one. If add these two numbers, if you add these two numbers, when this number and this number you have to add, what will happen? 1 plus 1 is 0. 1 plus 1 is 0 and this 0 and it is carry a 1. Means after D4, when you carry generated, then this is called, you have to set the auxiliary carries there. Then you have to set the auxiliary carries there. Then you have to set the auxiliary carries there. Okay. Then you have to set the auxiliary carry. Then you have to set the auxiliary carry. Means carries from lower nibble to upper nibble. Where carries from lower nibble to upper nibble, then auxiliary carry will be generated. And generates a carry from D7, then to next stage, then carry flag will be generated. This question is asked, what is difference between carry and auxiliary carry? What is difference? Carry flag means you have to generate a carry after D7. This is called the carry flag. And auxiliary flag means you have to generate a carry from lower nibble to upper nibble. Then the generate a carry is called the auxiliary key. What is mean to generate? Generate means you have to put value in D7 is 1, or if you have auxiliary carry generated, then you have to put a value of at the D4 is the 1 is there. When carry is set or carry generated means you have to put a value of 1. If the carry is not generated, you have to put a value of 0 is there. If carry generated, you have to put a value of 1 is there. Okay. The next part is the zero flag. Zero flag means what? If an operation is performed LOD values 8 bits, the 0 means if your result is 0, if your result is 0, then you can say that what we will say, if your result is 0, then you have to generate a zero flag. You have to generate the zero flag. You have to generate means what? What is the meaning of the generate? Generate means what? You have to put a value 1 into the digits where carry flag is. Carry flag is here 0 and here is a carry flag. You have to put value 0. This is the auxiliary carry flag. And then we are discussing the zero flag is there. Here you have to put the zero flag is there. Okay, understood. Then next is the sign flag. Next is the means result is 0. then your flag will be generated. The sign flag is what? What is meant by sign flag? Sign flag means if MSB bit is 0, the number is positive. If MSB bit is 0, number is positive, else number is negative. Means if this value is 1, then result number which is present in ALU is negative, and if S is 0, then the value is present in your ALU is negative. And if 0, it is negative, and if it is 1, it is the positive is there. Then parity flag there. Parity flag, if if result if result contains the even numbers of ones, means result is contain even numbers of 1, then you can say that the parity flag is 1. And if contains even number are odd numbers of 1, then this our parity flag will be 0. Means if our result is 1 1 and 1 and 0, if our result is 1 1 1 0, then how many ones are there? There are 3 ones are there, and 3 numbers are the odd numbers, not even numbers. So this parity flag put a value is 0. This parity flag put a value is 0. And if our result is 1 1 0 0, if our result is 1 1 0 0, then these two 1 are the even numbers. So this parity flag will be 1 is there. So this parity flag will be 1 is there. Means if your result is contains even number of ones, if your result is contain even number of ones, then parity flag is set. And if your result is odd number of ones, then parity flag will be reset is there. You must remember these things. Okay, so these are the 5 flags are present in your 8051. Also these 5 flags are there, and again 2 3 flags are increases. Same concept, there is a carry flag same in the 8051, same working of the auxiliary carry flag in 8051, same working of the zero flag in the 8051, same working of the sign flag in the 8051, and same working of the parity flag which is present in the 8051. But some another flags are there where you have to put the values of zeros and one depending upon the result present in your accumulator or in your memories there. Okay, so this is the flag is there. If there is a theoretical exam will be conducted, then in theoretical exam they ask draw the parity flag, and then draw the parity flag and explain the flags are there. So these are the flags. You have to draw this diagram is there, write down the flag, where is the carry flag, where is the parity flag, where is the auxiliary carry flag, where is zero flag, and where is the sign flag there, and you have to explain the things are there. Okay, then next is the instruction register. Okay, next is the instruction register where we are discussing right part of this architecture discussing. We are discussing first is the WH, then these are general purpose registers we are discussing, then we are discussing the instruction registers are there, and then we are go to the stack pointer and program counter is there. This is the flag register, we are part of the left side. This is the instruction register is there. Instruction register holds the opcode. Interpretation is holds the opcode, operation code or instruction code for the instruction which is been decoded or executed. It is written. See, this move a comma b. This is the one instruction. Just I am giving the meaning of this instruction is there. Move a comma b is what? The value present in b. The value present in b is transferred to the a. Move means what? Your value present in b is transferred to the a is there. Okay, so for that, if it is move a comma b, it is having one opcode is there. Opcode means what? It is having some hex code is there. This is called the opcode is there. Add b, it is having opcode is there. Sub subc, it is opcode is there. Here see mvid, mvid is having opcode, and this 50x is called the data. mvid is the opcode is there, and 56h is the 56h is the data is there. 56h the data is there. So every opcode, what is the instruction register is holds the opcode, means it is holds, it is not holds the data. Means in that instruction mvid 56h, in that instance mvid is the opcode which is stored into the instruction code, and data is stored into your data code or in another register is there. So the instruction code is only hold the opcode for the decoded or execution purpose. See, two lines must be remembered, or two lines, two words must be remember is decode and executed. Decode and executed, two different words are. Decode means what? Decode means what? The instruction we are write, you have to transfer these instructions into the hex code, or you can say the transfer the instruction into the binary code. You can transfer the instruction into the hex code, or also you can transfer the instruction into the binary code. After transferring the instruction of the binary code, after that we have to execute the program. After that you have to execute the instruction is there. Before execution you must decode the instruction. Before execution you must decode the instruction, means whole program is transferred into the binary code, and after that it will be executed. So you must remember what is meaning of the decode and execution. Decode means you have to convert the data into the binary code, and execution means the instructions which are given you, it gives the proper result of your program is there. Okay, so this is the instruction registers are there. Okay. Next is the program counter. Next is the program counter. It is very important part of your, I'm discussing last lecture, but this in deep they are discussing. Program counter is 16-bit register. Program counter is a 16-bit register. It contains a memory address. It contains a memory address. Okay. PC means program counter contains a memory addresses from the next instruction to be fetch and execution. Fetch for the execution are there. To fetch means retrieve. I'm discussing last lecture is there. To fetch means you have to take the instructions from the next location and then you have to execute the instruction is there. So if it is PC contains a 800H means 8085 desires the fetch instruction byte at 8000H is there. After fetching, program counter is automatically increment. This is very, very important. You must remember this thing. There is no need to type enter the enter key or no. Automatically our processor will take the next instruction, or you have to increment the program counter and the cursor will move to the next instruction. It is done by automatically. It is done by the automatically incremented by 1, and this becomes ready to fetch the next byte. Means what? Program counter is a 16-bit register. It store the memory address. If the address is 8000H is there, if you want to next instruction, then automatically the program counter will be incremented by 1, and then you will get the next instruction. You will fetch the next. Remember, another word is the fetch. How many words you are discussing in your? First is decode, next is the fetch, third is the execution. You must remember what is the fetch. Fetch means you have to take the instruction from the location. This is called the fetch. To fetch means you have to take the instruction from next location. It is called the fetch is there. Okay. So this is the program counter is there. Next is the how it work is there. So this is the memory location. So this is the memory location where you have to store the data. This is the memory location where you have to store the data. These are the locations are there. 001 to 6400 are the locations are there. What is the program counter is? Program counter is at the location is 001. After the line here, if writing any instruction is there, suppose move a comma b instruction is there, after execution or after fetch the instruction, then what will do? Automatically program counter will be increases and it will go to the next instruction. It will go to the next instruction, which is 002 is the location, and at that location there is some instruction is there. This instruction will be executed. This is the concept of the program counter. This is the concept of the program. What is the program counter? Program counter store the memory location. If the memory location at the location 0001 is there, after execution of the instruction which is present at that location, after automatically program counter will be increases and it will go to the next instruction where you have to put the value next instruction, then execute the instruction. After the execution of this instruction, the program counter will be next to the third instruction is there, then it will execute the third instruction, then again go to the fourth instruction. There is no need to write down any instruction to increment the pointer. One thing should be remember, there is no any instruction which is present to increment the program counter. It is automatically incremented. It is automatically incremented, which is the present in your processor is there. Automatically it is automatically incremented is there. You will go to the next instruction are there. So this is the program counter is there. Then next is the stack pointer. Next is the stack pointer. Then stack pointer is also a 16-bit register. Stack pointer is also 16-bit register. Okay, it is using memory pointer. portion of the RAM is there, last byte into the stack is there, data is loaded into stack. Just we are discussing is there. These 4 points we're discussing here by using this diagram. It's very easy to understand. Read this. This is called last in first out. Stack is last in first. See what is the stack is there. This is the empty stack is there. Okay. Then you have to put a value in this stack. It is called the push. You have to take. See, there are two instructions are present. Is push instruction and pop instruction. We are discussing at the time of your instruction code. It is push instruction and pop instruction. Push means that you have to put a value into the stack pointer there. So push one value here, then again one value, and then second value is there. Okay, so the push second value, and then pop means the last. LIFO means last in first out. What is it, how it works of the stack? If anybody asks you how stack is work, stack it work as a LIFO. Stack is work as a LIFO, last in first out. Stack is a LIFO, last in first out is there. One is you have to firstly put, after that you have to put 2 is there in the stack pointer, but retrieves first 2, and after that you have to retrieve the 1 is there. Okay, after that we have to require the 1 is there. So this is called a stack pointer. This is called a stack pointer is there, and stack is there. Stack is last in first out. It is a 16-bit register. Where we have to use stack pointer? Stack pointer is normally used in the interrupt programming. In the interrupt program, you have to use the stack is there. Means after the completion of the interrupt which is given by the controller is there, then again completion of this program, it will go to the main program is there, and for that purpose the main program next instruction is stored into the stack is there. Next program instruction is stored into the stack is there. So this stack is normally used at the time of the interrupts are there. This stack is normally used at the time of the interrupts are there. Okay, then instruction registers, decoder, control groups are there. You can decode the instructions are there, and then control groups are there. See, we are discussing here. See, instruction register, here is the instruction register, decoder is there. This is the instruction decoder. This is the instruction decoder are there. This also decoder is there. This stack pointer, we are discussing program counter is there, and then we are go to the timing and control units. Then we'll go to the timing and control units are there. Timing and control. These are the decoder as I am discussing what is meant by the decoder is there. When such instruction is fetched from memory, it is direct instruction register is there. So instruction register are specially stored the instruction that is fetched from the memory is there. Okay. So timing and control. Timing and control is used to consist of the oscillator, controller sequencer, then oscillator generate two-phase clock phase to add the synchronizing all the registers of the 8085 there. See, these are the control signals are there. We are discussing these control signals are there. What is the control signals are there? First control signals are ready. What is the meaning of the ready is there? First control signals are ready. Second is read and write, and next is the ALE. These are the pins which is present in your 8085 there. Ready means what? If you have to connect any memory to the 8085, if you have to connect any memory to the 8085, if ready is given, that you have to ready to fetch the data from your 8085, or you have to use 8085 for the working purposes. Give the given instruction by your 8085. I am ready to do the work is there. So we will discuss at the time of the programming on pin diagram what is the use of this ready instruction is there. Ready means what? Your controller is ready to work. It's called ready instruction is given. This read means what? Read is a low instruction is there. 0 means you have to write a data in 8085. Read means what? You have to take the data from your 8085. Write means you have to put the data into the 8085. Where 8085 means you have to put the data in your memory is there. This is the read. Write means you have to take the data from your 8085 is there. And ALU means arithmetic logic unit. What is, sorry, ALU means address latch enable, not ALU. This ALU is there, sorry. ALU is there. ALU means address latch enable. Where we have to use the address latch enable? Address latch enable is used. Address latch enable is used to multiplexing of address and data bus. If it is high, it is act as address bus, and if it is low, it is act as a data bus is there. This is called the ALE. These are called the control signals. These are called the control signals are there. Next is the status signal. It gives the status. Status means what? It gives the status. It gives the status. Status means what? It gives S0 and S1. These are the input pins. These are the input pins, serial input pins. You have to put that as serial. It gives the status if serial input is going on, or you have to out the input or in the input 0001. It gives the, we are discussing S0 and S1 pins. You have to connect the input output memory, then write bit, read bit. The next part. Then next is the input and memory. Input and memory. Where we have to M bar is there. M bar is the input output device or memory device. Means which device we have to use by the 8085. If this pin is 1, if this pin is 1, then it is act as an input output device, and if M is bar means this input is, this pin is 0, then it is act as a memory. Means you have to take the data or write or read the data from the memory when this pin is low, and if this pin is high, means status signals is high, then it will go to the, where it will go to the input output devices are. Then this is the DMA, direct memory access, the hold and HLDA, and it is for the reset in and reset out pins are there. Reset means you have to reset all the data which is present in your signals are there. So one by one your serial input output is there. See, it is carried by the instruction is input and output serial data. What is serial input data and serial output data is there. Serial input data and serial output data is there. Two more instructions perform the serial and parallel operations are there. Next is the interrupt signal. We're discussing the interrupt signals are there. Interrupt signals are, how many interrupt signals are there? Trap. Trap is the interrupt signal is there. This is the trap. Next is the reset 7.5, 6.5 and 5.5. This trap is non-maskable interrupt, and this interrupt request is there. This interrupt request is given by your outsiders there. Give the request to 8085 to do the interrupts is there. Just like write down how work me. I'm explaining deeply, but in wording when main program is executed from the microprocessor, some interrupts may arise. So to avoid the interruption of the microprocessor, shift the control from main program to the process of incoming request. See the line, you have to shift the control. Control means how, shift control means what in your controller processor. Shift control means what? You have to change the address. You have to change the address present in program counter. You have to change the address present in program counter and take the program counter is the address where the interrupt program is there. Where the interrupt program is there, you have to put the address of that where the interrupt program is there, and then cursor will be moved. The cursor will be moved to that point is there. Understood? What is meant by the shift the control? Shift the control means you have to change the address of the program counter. When you change the address of the program counter, automatically our controller, sorry, our pointer will be go to the program or interrupt program where the first line will be started, where the first line will start. So after the starting of this first line, it will execute the program is there, and after that it will complete the task of the interrupt is there. Then our cursor will move to the main program. How cursor will move to the main program? Again program, you have to put the value, the put the value of the previous address in your program counter, and automatically this cursor will be moved to the, where we have to move, where to the main program is there. So this is the, working of this interrupt is there. So how many interrupts are there? There are the 1, 2, 3, 4 and interrupt request. Interrupt request are for, and another point is the interrupt acknowledge. These are the interrupts are this. Priority of the interrupt is, see the interrupt priority is there. First you have to give the trap interrupt, this non-mask limited. After that interrupt 7.5, 6.5, 5.5, and lastly the interrupt request is there. Interrupt request is given by the outside to the 8085 is there. Okay, so this is the pin diagram of this. Pin diagram we will discuss afterwards. First we are overview of this architecture and then go to the pin diagram is there. See architecture we're discussing, but here we have to discuss all the architecture here. Then you can understand very well how the architecture is work. See, this is our architecture. How many? This is the 8-bit. This is the 8-bit internal data bus. Okay. Then this 8-bit internal database is there. Then we will go to the from top to bottom we will go. Then this is called interrupt controls are there. We're discussing interrupt control. How many interrupts are there? Trap, non-masculine interrupt, reset for 7.5, 6.5, 5.5. Then this is the interrupt acknowledgement, and this is given, the interrupt is given there. See, another point should be remember in your 8085, in any 8051 control map. This bar, what is the meaning of this bar? Interrupt bar is given, here is interrupt acknowledgement is given. What is the meaning of that? Interrupt bar means what? The value which is provided to the 8051 8085 by using this pin is 0. If the value is 0, means the value is provided by the interrupt request is 0, then this pin will be activated. This pin will activate when it gives the 0 value to the 8085. Bar means what? This pin will activated when 0 value is given is there. And here 5.5, 6.5, 7.5 is give the 1 to the 8085. Then these pins are the activity. Trap also give the 1, then this pin will be activities there. So these are the pins, reset pins, and these are the 2 pins which are the active low in your processor. You can say it is active low, and this is called the active high. Low means you have to put the value of the, you have to put the value. Sir, voice is breaking. हॅलो, व्हॉइस येत नाही का व्यवस्थित? हॅलो हॅलो हॅलो
येतोय सर.
हॅलो, व्हॉइस येत नाही का व्यवस्थित?
येतोय.
येतोय ना? ओके. See, this is the interrupt controls are there. This is the interrupt controls are there where you have to give the function. So next is this is the serial input control. See the pin, serial input is given to there and serial output is given by this pin. These are the 2 pins are there, serial input pins and serial output pins. Serial input pins and serial output pins are there. Okay. The next is the, we are discussing here, accumulator is there. Then this is a temp resistors. Then this is the flag. This is the ALU. We are discussing all the temp resistors are discussing, accumulator is for store data. These are flags means you have to see the carry flag, auxiliary flag, zero flag, parity flag. Okay, we are discussing these flags are 5 flags are there and 0 flag are there. Then after that, where you have to put the value of the instructions are there. Then we require the instruction decoder is there, means convert the instructions register into the, where you have to into your binary code is there. Then these are, we're discussing the registers are W and Z are the temporary registers are there. This B, E and L are your general purpose register is there, where you have to put the value of the 8-bit is there. Then stack pointer and program counter, the 16-bit registers are there. Stack pointer used at the time of the interrupts are there, and program counter we have to use at the time of your programming also. Okay. Then this is the, this is your address bus, and this is the database. You are discussing address bus database in your pin diagram, then you can understand. So only remember these things, database and address bus are there. So 8 to 250 is higher order address bus, and D0 D7 are lower order address bus. It is act as a multiplexing, means what? It is act as address bus and database are there. Then another important part is the timing and control circuit, timing and control system. See here X1 and X2. This X1 and X2 are used to connect a clock to the 8085. You have to connect the clock to the 8085. Another pin is the clock out is there. This the pin is for the clock out is there. Again, our send a request to the 8051, it is ready. If 8085 is ready or not, it is given by this instruction is there, ready stop. Then again read. See, read is the active low pin is there, means you have to give the 0 to activate the pin is the read, means you have to read the data. See the direction of the pin is there, direction from controller to the read is there, direction from controller to read is there. This is the read, means you have to take the data from the 8085 is there. This is active low pin, this is the active low pin is there. The write is also, you have to pin should be removed. You have to give the write to the 8085 there. This timing, this come from timing control is there. Write means you have to give the write data into the 8085 is there. Then this is the AL is there. The pins थोडेसे हे झालेत बघा. AL सुद्धा we are giving to the 8085 is there. This is the ALE means address slash enable. Address slash enable pin is there where we have to use the read and write data is there. Then S0 and S1. These two pins are used to select the hold pin, input pin is there. We're discussing in next lecture. These are the pins are there. S0 and S1 are there. Then here is the C. One pin is act as a two work is there. One pin is act as two work is there. Input, output, and memory. These are the input, output, and memory is there. If input output is means if this pin is active high, if this pin is active high, then it is act as input output devices there, and if this pin is active low, it is act as a memory devices. Means your controller is connected to the memory devices when your this pin is low, and if your controller is working on the input output device with input output devices, then this pin should be a active high is there. Then hold and reset data is there. Then hold and reset data is there. This is the hold and reset data. You have to reset data. Reset means what? You have to make the 0 to all the data. It's called the reset data. So this is the simple architecture of 8085. The same architecture, but this is same architecture, but it's very easy to in broad sense. That's why I'm taking this diagram is there. So this is a architecture of 8085. This is the architecture of 8085. Okay. So 5 minutes are remaining. If you have any doubts. काय डाउट्स असतील तर विचारा, त्यासाठी मी प्रेझेंटी घेतो तोपर्यंत. काय डाउट्स असतील तर विचारा. डाउट्स काय आहेत का?
Why program counter said 16-bit register?
सॉरी, परत एकदा विचारता प्लीज. काय म्हणलात? कळलं नाही मला.
प्रोग्राम काउंटरला 16-bit रजिस्टर का म्हणतात?
कसं आहे माहिती का, प्रोग्राम काउंटर जो आहे, द प्रोग्राम काउंटर स्टोर द डेटा ऑफ द 16 bit. Okay, suppose if I want to store the 8, if you want to store the 8 in the decimal number, okay, if you want to store the 8 in decimal number, how many binary digits are required? 8 means 1 0 0 0, required the 4 bits are there. Okay, then again if I'm again store the again 8 is there, then again 1 1 88 you have to present, we require the 8 bits are there. Okay, means if the value is stored in the register is 16 bit, means 16 bits means what? 1 0 1 2 is the combination of the 16 bits sir. म्हणजे 1 आणि 0 चं कॉम्बिनेशन जर 16 बिट्स त्याच्यामध्ये स्टोअर करत असेल, त्यामुळे त्याला म्हणतात 16 बिट काउंट, 16 बिट रजिस्टर. त्याच्यामध्ये 16 बिट आपल्याला स्टोअर करता येतात. 16 बिट रजिस्टर येतो, 16 बिट त्याच्यामध्ये आपल्याला स्टोअर करता येतात. आपल्या ह्याच्यामध्ये किती स्टोअर करता येतात? 8 बिट स्टोअर करतात. आलं का लक्षात? त्यामुळे प्रोग्राम काउंटर हा 16 बिट आहे, त्याच्यामध्ये आपल्याला 16 बिट स्टोअर करता येतात. अजून काय? जसं आपण विंडोज म्हणतो ना, 64 बिट विंडोज आर देअर, 32 बिट विंडोज आर देअर, सम रिक्वायर्ड मोर मेमरी, वन पिक्चर व्हॅल्यूज देअर. तसेच पद्धतीने आपल्याच्या प्रोग्राम काउंटर हा 16 बिट डेटा काय करतो? स्टोअर करतो, म्हणून त्याला 16 बिट प्रोग्राम काउंटर म्हणायचं. आणि प्रोग्राम काउंटर का म्हणायचं? इट इज स्टोअर द लोकेशन ऑफ द program instructions are there. So for that purpose it is called the program counter is there. आर्किटेक्चर समजलं का सगळ्यांना? एनीबडी समजलं सगळ्यांना आर्किटेक्चर? कारण आर्किटेक्चर जर समजलं ना तर इट्स व्हेरी इझी टू अंडरस्टँड द 8085. त्यामुळे आर्किटेक्चर समजणं खूप महत्वाचं आहे. तुम्हाला जर काय डाऊट्स असतील तर विचारा आर्किटेक्चर बद्दल. म्हणजे तुम्हाला हे तरी कळालं रजिस्टर्स किती असतात, पुन्हा how many registers are there, जनरल पर्पज रजिस्टर्स कुठले, स्पेशल पर्पज रजिस्टर्स कुठले. आहे का शंका कोणाला? सगळे प्रेझेंट तरी आहात ना? एव्हरीबडी इज प्रेझेंट इन क्लास. पर सगळ्यांना समजतं का? एव्हरीबडी अंडरस्टूड द. माझा व्हॉइस इथपर्यंत पोहोचते का? तुम्हाला पीपीटी व्यवस्थित दिसते ना? काय काय अडचण
Yes,
नाही
sir.
ना? एक मिनिट प्रेझेंट तेवढी घेतो, देन विल स्टार्ट. ओके, ठीक आहे. मग काय शंका नसेल तर आपण थांबूयात. एक मिनिट, चार्ट मध्ये काहीतरी आलंय. जस्ट रीड दिस. Okay, okay. If you understand, then we'll go to the next part. In next lecture is there. Practical session मध्ये आपण जे काय पहिले practical session मध्ये first two programs are related to your 8085. I'm downloading the one software is there. If you have PC, then you download 8085 simulator is there. You download this 8085 simulator. In that we are only do the program of 808 addition of or subtraction of the two numbers is there. And then for your 8051 you have to download the scale software is there. For remaining programs are there, all programs are under software is there. And if I am getting the 8085 kit, then we will go to the kit program. Only simple program of the addition means just I am giving the demo to you, the how to put the values, how to put the values of the hex values put in your this kit is there. 8085 is there. We're discussing this kit. If I'm getting in lab is there in your lab. Okay, so can I stop?